Hi students, welcome to Chemistry Chapter 6, Chemical Bonding. Also, hopefully you all had a very nice turkey. That probably will date this video from now on, but anyway, welcome back. We're going to start with Roman numeral 1, Introduction to Chemical Bonding. Under A, atoms are seldom independent particles in nature, but act instead combined with other atoms. Under B, chemical bond, a mutual electrical attraction between the nuclei and valence electrons of different atoms that binds the atoms together. Under C, nature favors arrangements with potential energy is minimized, creating more stable arrangements of matter. Under D, types of chemical bonding, please refer to Figure 6-1 out of your online textbook, page 162. Number 1, in bonds, atoms become more stable. That means they have less potential energy. Number 2, ionic bonding, chemical bonding that results from electrical attraction between large numbers of cations and anions. Opposite charges attract. They actually transfer electrons. Number 3, covalent bonding results from the sharing of electron pairs between two atoms. In purely covalent bond, shared electrons are owned equally by two bonded atoms. Number 4, ionic or covalent is the question. Under A, bonds between two different elements are rarely purely ionic or purely covalent. B, most bonds are in between depending on how strongly the atoms of each element attracts the electrons. Under C, electronegativity is the atom's ability to attract electrons in a bond. The type of bonding can be estimated by calculating the differences of the element's electronegativity. Table 5-20 on page 151. Please refer to that. Under D, valence electrons will be attracted to highly electronegative atom resemble anions, that's the negative ions, and the other to the lower electronegative resemble the cations, the positive ions. Under E, electronegativity differences that are less than or equal to 1.7 will form more covalent compounds. Under F, electronegative differences greater than 1.0 will form more ionic compound. Under G, two identical atoms combine so the electronegative differences is 0, so the bond will be 0% ionic and 100% covalent. See Figure 6-2, page 162. Under H, nonpolar covalent bond is a covalent bond in which the bonding electrons are shared equally by the bonded atoms, resulting in a balanced distribution of electrical charge. Under I, polar, P-O-L-A-R, meaning that they have an uneven distribution of charge. J, polar covalent bond, is a covalent bond in which the bonded atoms have an unequal attraction for the shared electrons. For example, between hydrogen and chlorine, the electronegative difference is equal to 0.9. So partial negative charge will be found on the chlorine end, and partial positive charge will be found on the hydrogen end. See Figure 6-3, page 163. We will then take a look at the sample problem 6-1, and we're going to determine the electronegative differences between sulfur and other elements, which is more negative. And then we'll have a couple practice problems when we get back to class. This concludes Chapter 6, Section 1 lecture. Because this chapter is rather lengthy, we're going to be probably breaking the parts or the sections up into different parts so that we totally do not put you completely to sleep. Anyway, have a very good day, and we'll see you very soon in class. Thanks.